Hi guys, in this video, I'll discuss designing Turing machine for this language. So this language is a language which has, uh, we have to design a machine which accepts a language which contains equal number of zeros and equal number of ones, where there should be at least one zero and one one. So that's the language our machine should accept. So what I'm going to do is I'm going to discuss a strategy that you can use to design a Turing machine so that you can apply the same strategy to other problems as well. So that actually to design a Turing machine, the most challenging step is to like identify what to do to that the step one is like how to design this. How to go about doing this. So that's the idea that you will have to think about. Like it differs from one question to another, so you cannot use the same idea for all the questions. So that's the problem with not the problem. Actually, that's what you have to like think about it. But the other steps are like you can just follow the same strategy for all questions. So so here, like we have this tape, right? So this is the, let's say this is the tape, and then it can extend to both sides. So to like design this machine, you can. Okay, the first step is to identify the idea, right? So let's say we have the string that we have is like 0 0 1 1. So that's a valid string because it has two zeros and two ones. So the strategy that you will have to use is like to know that. So we know that the head can move to the left or right, and it can read one symbol at a time, right? So when it starts from the first input, so like the leftmost symbol, when it sees this, uh, so there should be a matching one corresponding to this zero. So we have to like search for that one first. So the strategy is like the idea is we cross this zero, like replace this zero with x. So we replace this with x, right? So right on top of it. So we cross that off. Then we move right and search for a matching one. And as soon as we find a one, we replace that with a y. Now we'll continue the same thing. Like we'll move left and find the next zero, right? So and then cross off that zero, and then move right and find the matching one. Replace it with y. And now, if there are no more zeros and ones in your tape, right? When you scan the tape, there are no more zeros and ones. Then you can accept this string. So that's the idea. So this idea we have to think and find. Then uh, to draw the like transition diagram for this, we can use the same strategy for like all questions. It's the same strategy. So here, like you have to look at the different possible scenarios that you will encounter when you scan the tape. So, for example, first scenario is this, right? Like you have two zeros and two ones. That's what you start. So, any machine should have a start state, right? So, we can call that state as A. So, when you start the machine, as of you have to like first you encounter zero, right? So when you encounter zero, you are not just you're not just skipping, or you're doing something, right? You have to replace that zero with x. right? So the second scenario will be like this. So once you do that, you get x 0 1 1. So so this is the strategy. Whenever you change something like the direction or the tape symbol, you can include a new state. So that's the strategy that you can follow. So here we are encountering a 0, and then we are replacing that 0 with x, right? So there is this sometimes different textbooks use different notations. So that's where you have to be careful. So I mean, you can use any notation, but then you should stick to one notation. So when you encounter 0, so I'm following some notation that I have here. So when you encounter 0, you are replacing it with x, and you're moving right, because we have to now search for one, right? So the like I have included a new state because I have made some change, right? I have replaced 0 with x, and then I'm moving right, right? So I go to a so now I go to a new state. So that I can call as b. Now look at this. What can happen when you are in b, right? So this is the second scenario, right? When you are at b, uh, like you can encounter a 0, right? Uh, so when you encounter a 0, we are actually not searching for 0. We are searching for 1. So we have to keep moving right get uh, until we see a 1, right? So in b, we are not changing anything, right? So when you encounter a 0, sorry, I just keep putting comma. So when you encounter a 0, you can just replace, I mean, not replace, you can leave the tape symbol unchanged and keep moving, right? So here you see that we are not making any changes, so you can stay at the in the same state, right? Okay, now what will happen if you see the first one, right? So first one is x, so which means you have now moved one, and then you have reached one. So what I'll do is I'll replace one with y, right? I'll replace one with y. So this is another scenario that we encounter. So when you replace the one with y, you are again making a change, right? So you can include a new state for that. So which means it will look like this. So I'm seeing a one, so I have to replace that one with y. And now where should I move? Since I have now seen a Since I have seen a 1, now I have to go back to the next 0, which means I have to now move left, right? So I'll move left. Okay, so we have reached a new state. So we have included new state because we are doing some, maybe not, I mean, we are making some changes. So that's why we have reached C. Now, when you reach C, this is the scenario, right? So now you are moving left, and then on the way or left you can encounter a 0, right? So when you move left you can encounter a 0. So when you encounter 0, uh, we don't have to because we don't know whether it's the leftmost 0 that we have on the tape now, so we have to keep moving left. So that will be 0, and then I don't make any changes, and I keep moving in the same direction, which is left, right? Okay, so okay, now if we again move left, right, we now see a x, right? So when you see x, now you know that uh, there are no more zeros to the left of x. The next zero after x is the I mean the first 0 that you're looking for, right? So now if I see an x here, which means now I have to move right and look at the next zero, right? So here, so which means I'm like restarting. I'm going to start doing the same thing, because in the first state when I saw a zero, I marked crossed it as x and then moved right. So here when I see an x, I know that uh, I have to move right and see the next zero and cross it off. So which means I have to go to the start. Okay, this my pen is. Oh, okay. So go to the start state. So why did you do that? Because you saw an X, right? You saw an X, and then you're not changing the tape symbol, but then you're changing the direction, right? You're moving right now, because you have to now uh, search for the zero, X zero. So you'll now see the next zero, and then you'll cross it off with X, 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 Y. So you'll cross it off with X and then move right. So you continue this. Go to B. Uh, okay. So now here, this is the next scenario that you have. So you have crossed off the second zero with X, and now if you move right, what you see is a Y, right? But we have transition only for zero in state B. When you see a zero, you have to leave zero as it is and move right. That's what we have written here. But we need a now we have seen a y. So in state B, if you see a y, you have to decide what to do, right? So if you see a y, that's not what we are searching for. We are actually searching for one, right? So which means you don't have to change anything. So I mean, if you see a y, then we can leave y as it is and move in the same direction. So which means I'm in the same state now, because I'm not changing anything, right? So now I have a I move right, right. So now I see a one. Now I see a one. Okay. So we are in state C. No, we are in state B, and I have seen a one now. So I'll replace it with y. So I have that transition already here, right? So I'll look like this: x, x, y, and then I'm replacing one with y, right? And then I'll move left. So I'm moving left, and now I see a y. So when I move left, we are now in state C, and in state C, I don't have a transition where I see a y. I only have a transition where I see a zero, right? So when I move left, I'm not actually looking for a y. I'm looking for an x. So even if I see a y, I can just skip it and keep moving left. So I'll have this function. Why you don't change anything, you still keep moving left. So which means you are in state C itself, right? Okay. Now on the way back, you see X right next. So we already have the transition in C. X. You don't replace X with anything, but then you move right, right? Okay. So this is the like state where you're done with everything. Now if you move right, you see a Y, right? You see a Y, but look at where we are now. We have seen an X, and then we moved right. So we are in uh, we are in state A, and we are seeing a Y, but we don't have a transition for Y in A. So now we have to decide like what we have to do. So we have seen a Y, so we have to make a new transition. So we have seen a Y. We are not going to do anything to the y, but then we are going to keep moving right. Right, so you can call this a new state D. Okay, so we have reached D now. So what's our task now? We have to like check if there are any more ones on to the right of the tape. So we keep moving right until we see a blank, because on either side of the tape we'll have blank, right? So here you'll have a blank, here you'll have a blank. So we'll keep move right. So if you see a blank, then we can accept this string, right? So in state D, if you again see a y, right? So which means we were here and now we move here. We are seeing a Y again. So we don't have to do anything. We have to just keep moving right. Now, finally, if you see a blank, right, that's when you accept this string, right? So when you see a blank, what do you have to do? You don't have to do anything. You have to leave the blank as it is and move one step left, which means like if you are here, you have to just move left at the end of the input, and then you have to accept that uh, string. So this I'll call accept, right? So that's how you can draw a transition diagram for this Turing machine. So this question is like for n greater than or equal to 1. So it can also be sometimes n greater than or equal to 0, which means if you don't have any zeros or any ones, you still have to accept the string, right? So which means in the start state, which means when you start itself you see a blank, right? So you can include that as a directly you can go to the accept state because you have to accept that as well, right? So you'll do something like this B, and then you just move left, right? So just making sure that there are no symbols to the left. So if you see a B, then you just replace that. Uh, I mean, you don't do anything. You just replace B and then move left, uh, and then just accept this thing, right? So that's how you can do. So this is the strategy that you can follow to design a Turing machine for a simple problem like this. So like I said, the initial idea is what where you'll have to think about, and for the rest of the things you can use. I guess you can use the same strategy for all the questions. But the important thing that I wanted to mention is right when you before you draw all these transition diagrams and all that, I suggest that you the steps in write the steps as a write the steps in English. I mean, without using symbols or anything, you can just write it in English. So like you can, for example, I'm just showing an example. You can like so like if you encounter zero, replace with x and okay and move right. So I'm just showing you one step. So you can write all the steps in English so that the person who's reading your answer paper knows for sure that you know how to do this, because like notations can be different, right? So I have used like zero x comma r, but then there are other notation like slash and things like that. So if like they get confused, there is a chance that they don't know this notation or they don't know this. So to be on the safer side, write down all the steps in a readable language. Then you can use symbols. Then you can draw the transition diagram. So make it a complete answer. Okay, so we will do a few more questions from the previous university question papers. So see you in the next video.